presentation for Nick here, but you can read it in the book, and I'll just turn it over to Nick to give her a whirl. This thing's supposed to, you got an hour, it looks like, so I'll wave at you when you're getting close if you need it.
This thing come out. Good afternoon, everyone. Guess we'll get started here. Yeah, we'll talk about a little about foliar biology. 2-3 years ago, Michael and Bryce and I were talking about what we're doing and the link that we're seeing between the two, and thought that'd be a topic that we could cover. So I'm going to run through some things and questions. Stop me anytime. I mean, that's what this is about. It's Q&A, and so we're going to be telling you guys kind of a little bit of what we're doing, but then we're also going to cover the basics. So basically, what's a foliar? If there's anyone that doesn't know, basically, anytime you spray something directly on the plants, applications can provide a valuable boost plant growth and yield, particularly in low nutrient soils or during periods of stress is kind of what we recommend. However, it is not a replacement for fertilizer, you still have to have your normal fertilizer program. So I saw Danny had this as carbon. So what's missing? This, I don't know how long this slide's been out, but probably 20, 30, 40 years. She had carbon, this missing there is coming out, and for us it's biology. We've never seen biology in any of the yield deals because it's always a add on more of the soil, chemical, physical, and biological, but biological has never been part of when you talk about high yield or anything like that. You talk to guys like Russell, and he kind of is proving us wrong that you can use biology, and it does have a lot of yield potential if you do it right. So how foliar can help biology? So you can increase photosynthesis, increase exudation, production of plant hormones, PGRs, and induce systemic resistance. So we cover that a little bit. How do we know it's working? So last year, I don't know if Dale's here or not, but he pulled the samples. So we went to 3 different fields, actually 4, but we just used 3 for this little exercise. But we went and pulled 3 5-foot cores from 3 different fields, and then had Willie at Ward Labs break them up into 0 to 6 inches, 6 to 12, and then a foot every down there till 5 feet. So we pulled these. We run them for a soil health test. We run a total nutrient digest test. We run a PLFA on every sample. So I think we worked out it's 18 times 4 of tests that we ran. So this is what the first one was. I'm going to switch hands here. So this was the first one. I just had that. That's what they look like. Soil health assessment, Fields Matthews, Southwest quarter. Basically, what we're going to show, this is the 0 to 6. Try and find this. So 0 to 6 inches, soil pH 7.2. You guys can go through what's available here. For this exercise today, we're not going to focus on that a whole lot, even though if you look at zinc, 10.5, that's a lot higher than what you generally see in a normal soil test from the normal labs. But from the soil health deal, we're going to look at the respiration there, 62, and we're looking at soil health score, 9.98. So again, that's a reflection against ourselves. That's not something really that we're going to measure with other farms. It's basically a baseline that you start. This farm has been 4 years into our rotation. It was 100% tillage before that. This would be the totals test from that same field. So again, same sample, just a different test. Something that jumped at me, everything is quite a bit high, but if you look at the phos, it's really low for a totals test for the top 6 inches. Carbon to nitrogen, or calcium magnesium ratio, like to see the calcium a little bit higher to get to 1 to 5. So that's something we're going to be working on going forward. So that's the top 6 inches. So this is the bottom foot. So this is the sample from 5 feet to 6 feet. Look at what the pH it does from 7.2 down to 8.6. So we gained, oh shit, it just went that way. So it gained from 7.2 to 8.6 down to 5 feet. The other deal we're seeing is the phos went up quite a bit, and the soil health went down, respiration went down big time. So at 5 feet deep, we're not seeing the biomass and the amount of activity that we're seeing in the top 6 inches, which should be pretty normal, making sense. What is kind of weird for us is how much salts and how much fertilizer we've pushed down through that bottom layer through 50, 60, 70 years of fertility, which is the only thing that makes sense for the bottom pH to be that much higher than the top pH. So soil health score, not that good. Respiration, not that good. Totals, looking at the phos down deep, 1,600 pounds. Everything else, there's more than enough available to get there. Something interesting as well, even down deep, our calcium-magnesium ratio is still a little bit out of whack. Okay, so observations from just the soil health and the total digest test. pH lower on top, some nutrients lower on top, pH salts become higher the deeper we go, also more nutrients below. So that brings up the questions, what we wanted to see. Are we reaching these deeper nutrients with the biology? Do we have the biology to utilize these deeper nutrients? And why are we not testing for these? So when we do soil tests every year at 6-8 inches, why not do a core test once every 2-3 years and just see what you have available? Because every fertilizer program that we basically analyze for, test for, and write a prescription for, we're basing that off the top 8 inches and drawing up a whole program for the top 8 inches, but our roots go deeper. And so why are we ignoring everything below that? So this is from our AquaSpy probe. This was taken beginning July in the middle. And then I think the left one, that one's the 15th of July, that one's the 18th of July. So by the 18th of July, we were at Tassel, had a pretty good rain, so you can see we're saturated on the probe. Roots, 48 inches deep. And so usually around 10 leaf to tassel, we get to 4 foot. So my point is, back to this deal here, we're not measuring anything in a normal scenario down there, but when you look at the roots, our corn roots go down there. They access these nutrients. Well, what are they accessing down there? Why are they going that deep? Are they associating that deep? Are they exudating that deep? What are we seeing back from that? So, self-imposed observations and questions. Against everything we do, we inflict on ourselves. So roots seem to go down without problems. Are they delivering sugars and associating with the BioLife? Well, we don't know that yet. Is our Bio 800 application traveling down with the roots? We use a biological product that we put out every year, and for the last 4 years we've done it. So what can we improve? How can we make this better? So this is the first PLFA test. This is the top 6 inches. I'm going to focus basically on 2 things on this page and then one on the second page. So the first thing we're going to look at is there. And so total living biomass, 1,200. You look down there, we're in that basically slightly below average. And this is in the top 6 inches, so this is where we're supposed to be high. You look at the diversity, and we're 1.5. Well, 1.5 is good. So we might not have that much, which, if you think about it, where we are in the desert and really tough conditions, really harsh heat, it would make sense that we might be low, but our diversity is still pretty good. You look at the next page of this, and it gives you the fungal bacteria ratio, and a 0.28 is still good on this slide here. So we're keeping the ratios pretty good, even though we're slightly below. Protozoa still available in the top 6 inches, which was funny because in every sample we took, the top 6 inches we had protozoa, everything below that, nothing. So our protozoa is active in the top 6 inches, but below that, even though we have the fungal capacity and numbers, we don't have the protozoa yet. So we got a lot of work ahead of us. So this is 6 to 12 inches deep. Same field, same sample. 1,300. So now we're moving up a little bit, still slightly above average, but at least went from below average to above average. So why, again, if you look at our drought, we affect the top 2, 3, 4 inches. Our wind, we got an evap of 110 inches. So we're pretty harsh on top, which is the conclusion we kind of came to of why our 6 to 12 inches is showing a lot better numbers than the top 6 inches. 1,358, looking at 135, slightly above average. So both of them in this sample came back pretty good. You look at the composite ratios, fungal to bacteria, we took a big old dump there. So that's interesting because we're showing a lot more biomass and a lot more diversity in the 6 to 12 inches. But when we looked at the bacteria to fungal ratio, we went from pretty good to 1.5, which is average. So again, these are the questions that we have no idea what we're seeing, but we're trying to figure out why we're seeing it, looking at our program, looking at our biology, seeing how can we change that. Then we jumped and went to the second last one, which would be 3 foot to 4 foot deep. You can tell the biomass went absolutely down big time. So it matches what we saw in the earlier tests that we're not seeing. So pretty basically, if you look at 529 over there, it's poor. But you look at the 135, and we're still slightly above average on fungal to ratio. So even 4 foot deep, we might not have a whole lot of activity, but the activity is still balanced. We still have fungi down there. So we are feeding them with the roots that's going down. You look at our fungal bacteria ratio, we're 2.5, 2.4. We're in that one slightly above average. So we're still pleased. We're still maintaining the ratios. We're not bacterial dominated 4 foot deep. This is 4 to 5 feet deep. So this is the very bottom sample. Again, biomass went down. Diversity index still pretty decent, slightly above average. Fungal bacteria, really big surprise. The highest concentration we have, and I talked to Willie about this yesterday, and he was telling me that a 0.3 is basically a 1-to-1 ratio in a microscope. So the way the PLFA works, and if Lance is here, he can tell me, but the way this works, a 0.3 on this scale, the way they measure the cell wall strength of the bacteria versus the fungi is about a 1-to-1 ratio of fungal to bacteria ratio. So the fact that we have a 4.2 at 5 feet deep tells us that the corn roots is getting down there, is feeding the bacteria, is associating with the fungi, because we are seeing these numbers increase down deep. So how did we get our biology to work for us that deep? Well, we've been using photosynthesis in turbo mode, and we'll get to that, exudation, strive for a balanced plant, and notice the bottom, not a moron mode. So we don't try and increase everything. We're trying to keep it balanced. And for those of you that haven't heard me talk about the moron farmers with the moron approach, that's when your agronomist tells you just put more on. And I deal with a lot of guys like that in several deals. We try and be balanced. You can have high yields and still be balanced. So increasing biology. Increased photosynthesis generates a higher amount of sugars. This gets transported to the roots through the phloem. Plants exudate these excess nutrients in the form of organic acids, enzymes, amino acids. These exudates attract beneficial microbes to form symbiotic relationships with the fungi. And that's what gives the plants the ability to access more nutrients, more water, deeper, where you build these symbiotic relationships. So leaf size matters. Something I picked up from Graham Sate probably 10 years ago is leaf size can impact the overall yield of plants. So larger leaf size generally allows for more photosynthetic surface area, resulting increasing energy acquisition and conversion into biomass. And then basically the size of the plants directly affects the rate of photosynthesis. So larger leaves might have a higher concentration of chemical defense compounds. And that's basically, if you finish it, that's basically how we start getting the bricks to go higher. Plants release various chemical compounds, and then they basically associate with that into the rhizosphere and the phyllosphere. And we're explaining basically here the two zones. So that's phylospheric and rhizospheric. So the plant not only associates with it underground, but it also associates with insects and the environment in the above plant. So it gives you both access or both environments that you get the positive reaction from having the bigger leaves and bigger photosynthesis. Whether it's ladybugs, whether it's excretion, whether it's environmental effects that you get. So inconvenient outlier, I was just talking with Chris about this in Iowa, and he's seeing the same thing. So it's kind of nice when you have crazy ideas and you're not the only one that's in the nut house. But so GMO crops, if you've seen Common Ground, you have seen and heard a lot of, it's basically in the Acres magazine of this month about how GMO crops will not associate with mycorrhizal fungi because they are bred to not do that. Well, we're waving the flag on that because we're seeing the opposite, and we're seeing that if you create an environment that is very beneficial, and with the quorum sensing that Christine mentions, that even the GMO plants will associate and will basically thrive on that high fungi environment. So on soybeans, corn, sorghum, we have found that varieties with bigger leaf size and better canopies have always worked for us out west. So why? Are we onto something? Are they tougher? Do they adapt better? So we're trying to dig into that deal as we're going on. By overstimulating photosynthesis and promoting biology, we seem to overcome the deficiencies that certain GMO technology have been associated with and blamed with. So basically, we're trying to not show, but trying to prove in the next 2-3 years, and we're going to work with basically shaking off roots and seeing what's associating with the roots and different hybrid plants, different GMO varieties, different milo varieties, modern hybrids. So we don't necessarily are telling guys that you have to plant a heirloom corn to have the association. You can have that with modern day hybrids. Okay, so building blocks of photosynthesis: calcium, magnesium, phosphorus, boron. On the other side of the aisle, you got sunlight, water, carbon dioxide, and enzymes. Those ones being in balance is pretty important to have photosynthesis go in what we call turbo mode. So for those of you that know me, I don't do a single presentation without this chart. Because if you have not seen it, you need to see it. You need to Google it, you need to research it. Because if you can't keep this balance, you are going to create yourself a deficiency, guaranteed. You're not going to have high breaks. You're not going to have a healthy plant. Something interesting I was going to tell Danny earlier that Graham Say taught us: for every pound of nitrogen that you over apply, you burn 100 pounds of organic matter. So do the math for these guys that go every fall and put out 300 pounds of anhydrous on a CEC of 8 or 12 with organic matter of 1.2. Go do the math, and then you look at the sine wave that they always proud to remind you of, that they grow in the summer and build carbon in the summer, but they forget to mention that the sine wave is flat at the end of the day because they lose it every winter. So when you can't keep this together, it's hard to build anything and to get the ISR that you want to have. So all roads lead to Rome. Calcium is the trucker of all nutrients. That's a pretty good saying of Graham Say, that he starts with everything that he does. Improves cell wall strength, plant structure, better cell wall integrity, makes plant more robust, preventing lodging. I've got a challenge on with an agronomist this year. If we put calcium on wheat, we can raise 100 bushel wheat without picking it off the ground. So we'll see how that's going to turn out. Increase the ISR. What is ISR? Basically induce systemic resistance. And basically all that's saying is, if you have a healthy plant, not only is it going to basically be resistant to insects and pathogens, but through mycorrhizal fungi, it's also going to tell the whole rest of the field and make the rest of the field the same resistant. So you can start with one plant, but eventually you have a whole field that triggers a defense system wherever that field's attacked, and then start defending itself. So what do we need to apply and why? And the whys is what makes me kind of trigger about what we're doing. And some of the things is easy. Some of the things you got to do some research. And sometimes you do the research and you get 5 different answers, and then you got to Google the 5 different answers to figure out which one's right. So magnesium's pretty easy. One of the key components of chlorophyll pigment that gives plant the color. More chlorophyll leads to increased photosynthetic activity, improved energy. Also helps to plant resilience to environmental stressors such as drought, heat, and disease. Essential for activation of enzymes involved in phosphorus metabolism. Also, basically on every foliar, on some we put it, on some not, but none of the foliars, it matters where your pH is or what your soil levels is or what your soil tests show. So you can correct a deficiency in a plant irrelevant of what the soil condition is like. So that's the key of the foliar deal, is you can help a plant without having to have a problem below the soil. Phosphorus, vital role in root development, cell division, energy transfer. Highly beneficial as a foliar in pH-challenged soils. Vital for flowering, fruit production, leading to higher yields, higher quality crop. Improves plant resilience to resist stress and diseases. You'll notice that on quite a few of these too. Boron, essential for plant development and growth. Gramesite calls it the trucker. Calcium, boron's a steering wheel. Crucial formation of cell walls, key nutrient for transportation of sugars and carbohydrates in the plant. Basically, every day the plant builds up sugars, stores it. Every night, boron is the one that opens up the gate, let the calcium take all the sugars, moves it to the roots. That's how you have the exudation. That's what feeds the microbes. Every morning, that comes back up, opens up the gate, starts building up, or shuts the gate, starts building sugars again. If you're boron deficient, you don't cool down at night. When you had a hot day and you go at night, if you're boron deficient, that's when you start seeing red leaves because the sugars keep building up and you're not releasing it down into the roots. So be sure to make, if you're expecting heat or a heat wave or drought, do a tissue test, do a sap test, make sure you're not boron deficient, because that's key in helping you through that. Helps plants to regurgitate water, and steering wheel. So nitrogen, what I call the moron nutrient, because it's the most over-applied one in ag. One of the fastest to respond nutrients is a foliar. I think Joe Williams told us, 3-4 years ago, like 2 or 3 hours on rye from the time it's sprayed till it's in the roots. So it's really, really quick. Highly effective in alkaline waterlogged soils. Quick aid to help with overall health and vigor. And for every pound that you over-apply, it burns 100 pounds of organic matter. So that's the one that you want to not over-apply. Nickel and urea. So nickel acts as a catalyst, and the reason I went on to nickel is Russell mentioned that in his high yield deal, how he and Liz Haney started playing with nickel on soybeans and then pulled it over to the corn. So I started looking into nickel, and so it acts as a catalyst, increasing the rate of reaction and lowering the activation energy, making the reaction proceed more quickly and efficiently with nitrogen. Facilitates the enzyme urease, which catalyzes the hydrolysis of urea into ammonium and bicarbonate ions, reduces losses through volatilization, and then 0.1% urea suggested at rates, but if you look at what Russell applied, it was way less than that. He applied like a gram per acre. So something to play with, adding that to your nitrogen, foliar or in furrow or through your pivot, whatever you use. Play with some nickel in your nitrogen side strips, see what you get for effectiveness. Sulfur, key component, production of amino acids, essential for the formation of new plant tissue. Fungicidal properties. If you think about when you get hail, that's one you want to put on when you get a hailstorm. Make sure you have sulfur in that mix. If you're going to put a fungicide on, that's fine, but make sure a little bit of fulvic acid, a little bit of sulfur. That's one of that's going to get you to get the new tissue to pull it out, and it's going to, give you some fungicidal properties.
What kind of sulfur are you running in the foliars?
I use mixes usually that comes out with some sulfur in them. So I don't use just plain sulfur, and we'll get to that in a little bit on the reduced rates, but we usually try and find mixes that have sulfur in them. Increased photosynthesis due to the role sulfur plays, enhances the plant's metabolism and the ISR. Potassium, essential for water regulation, enzyme activation, photosynthesis. In Chris' area in Iowa this year, Illinois, a lot of potassium deficiency in plants late. Caroline's in the back, soy sauce, potassium, one of the probably leading products on the market right now for this. Highly effective as a foliar to reduce stress. Again, if you think about it, when there's stress coming, boron's one, potassium's the other one. Make sure you're adequate in potassium on sand tops. When you have fields that's got sandy hills, that's usually where you're potassium deficient. If you do grit samples, you'll see that. But even if you do tissue or sap analysis, usually the stress spots, the high sandy spots, low organic spots, make sure your potassium is adequate there. Key nutrient, regulated water uptake, improves the quality of fruit set. We know that. That's why potassium is being used late in the corn plant, but something that guys are not, that we learn out west with as much stress as we have, that potassium is pretty important when it comes to that. Manganese, key nutrient, photosynthesis, enhances stress tolerance by activating antioxidant enzymes, and then also helps plant to withstand environmental stresses like high heat. So there's another one you can add to your list for stress is manganese. Make sure you got something that's got manganese in it. Zinc, most common foliar to bypass soil-related issues. If you think about soybeans and iron chlorosis, iron and zinc is usually the two that you put on for iron chlorosis in soybeans. Crucial in enzyme activation and various metabolic processes, and then also better fruit set and development. If you looked at that slide on early, if you remember, we were 10 and 17 parts per million on that zinc. That's about 8-9 times at what my neighbors are. So we're usually 0.5, 0.8 to 2 parts per million in my area is pretty typical. The fact that we're 10, 12, and the fact that we're 10, 12 available in every layer of that foot is pretty impressive for the biology and the reaction that we're getting.
Where did that come from, Dave?
That's, my assumption would be, that's the activation, the mycorrhizal fungi that's been making it available and accessing it to the plants. And also when the plant residue deteriorates, so when those roots start deteriorating and breaking down, when the saprophytic fungi starts breaking that apart, that's what's left over. So we're seeing it being mineralized or, become available. But we're seeing the same thing with phos. We're seeing the same thing with potassium. Like we have, when we do a totals test, we're the same as the neighbors, but when we do a soil alpha or Haney, we have a lot more available. So that's the assumption we're making. Molybdenum, instrumental in the conversion of inorganic nitrogen to organic compounds, aiding in the synthesis of proteins and enzymes, enhances plants' ability to fix nitrogen. So this is the first one now that we're seeing is pretty critical in making atmospheric nitrogen. So when you have a corn plant, which we are told can't make nitrogen by itself, if you look at the guys that are super boosting some molybdenum, we're seeing the pictures like you showed me earlier, where that corn plant is actually starting to fix nitrogen by itself and pushing it down to the roots. So bypass the soil binding issues. So molybdenum, make a note on that for helping you create more nitrogen. Iron helps addressing iron chlorosis, necessary for the synthesis of chlorophyll. So one of the key components of making green, making sugars. Key component, if you think about iron chlorosis in beans, why is it yellow? Why is it not green? Because you're not making the chlorophyll. You're not building the sugars, and that's why that leaf is yellow. So key component of enzymes involved in energy production, photosynthesis. Again, why you're not seeing, if you look at the lack of chlorophyll, that you're going to have the lack of photosynthesis, which the one always works with the other. And then vital role in metabolic processes of plants. That's generally a lot of the nutrients are seeing that. Copper. Ability to control fungal bacterial diseases, suppress the spread of certain viral infections. The organic guys use copper a lot. Unfortunately, a lot of them use it in the soil. It does become toxic when you overuse it in the soil. It's a lot harder to become toxic using it as a foliar. So as a foliar, you get more of the fungicidal actions to it without become toxic in the soil. So that's one key difference with copper, where it's a lot better used as a foliar than putting it in soil. By providing the necessary micronutrient for enzyme subfunction, copper can improve photosynthesis, nutrient uptake, and directly as a foliage, copper toxicity in the soil is minimized, which I just mentioned. Aluminum. If you think about the sticks that you use under your arm that everyone tells you not to use that causes cancer, we'll ignore that. But aluminum, if you associate aluminum, it stops respiration. So if you look at the aluminum in the plants, enhances the natural defense, promotes plant health, effectively increase the uptake of utilization, assists to regulate plant water balance and transpiration rates. So there's a lot of elements that does exactly the same thing in the human body than it does in a plant. And aluminum is one of them. So if you are aluminum deficient, you're basically going to be less stress tolerant and not have as a robust plant. So if you check your aluminum levels, which a lot of labs do and not do when they check, but make sure, again, when the drought's coming, when the forecast tells you there are 6 weeks of 100-degree weather coming, make sure you're not aluminum deficient. Helps conserve water, maintain physiological functions, even under stress conditions. So basically what it does, it slows the respiration down in the plant, just like a fungicide does, because that's a key component of a fungicide in corn. It slows respiration down. It makes that plant more stress tolerant. Well, aluminum is doing the same thing, but it's actually doing it in a natural way through the plant, not through a fungicide. So something interesting about aluminum. Cobalt. Key component of nitrogenase, the enzyme responsible for converting, again, atmospheric nitrogen into form plant can use. So we had the one earlier, now we got the second one. Big part of nitrogen-fixing legumes. So when you got soybeans, when you got cowpeas, when you got alfalfa, this is one you need to check for all the time, because that's the one that's going to produce your nitrogen for you. Big part of fixing legumes, crucial role of B12, a lot of metabolic processes also help to improve plants' tolerance to stressors. So again, not as big on the stressors as the aluminum would be or the other ones would be, but still part of it. Again, look at the molded chart, you got to have the balance. Silica, big component of the ability to strengthen cell walls. Again, if you listen to Graham's site, silica is the one that can get you to basically become insect resistant. A lot of guys are looking at it for sorghum, for aphids. This is the one that is going to do it. Works in synergy with calcium and boron to strengthen cell walls, because that's what moves it. Improves the structure, rigidity of plants, preventing lodging, and also makes it more natural defense. Selenium, crucial role production of antioxidants, immune system, enhances efficiency of photosynthesis, aids in activation of enzymes. Aloe, this one's for Michael. I don't know if he's here or not. But antifungal, antibacterial, aloe is a stress drought resistant aid, aids in preventing plant diseases in humid environments. You go east of here, I consider you guys humid. You go west of here, we get dry, we eat. So maybe not something out west that we're going to look at in the humid environments. Aloe also contains natural PGRs, so plant growth regulators. So improve a plant's ability to absorb and utilize nutrients, making more resilient, which you've seen on several aloes. There's a lot of studies out there on aloe, spraying aloe, even putting aloe in furrow, putting aloe through nitrogen. A lot of data out there that making plants more stress resistant in droughts. So one of them that you can use, several products out there that have aloe. Molasses contains a lot of essential minerals. A lot of us use molasses as a carbon source with our nitrogen. It's got iron, magnesium, and potassium in it. Contains sugars and carbs, which acts as a source of energy for beneficial microbes. A lot of us spray it on soybeans for microbes. Can also help to attract and retain beneficial insects like ladybugs and lacewings when you do use it, like on sorghum. So you can try and spray molasses on sorghum, try and get some of these in, and also be preventative on the sugarcane aphids. Stimulate the production of phytoalexins, which are compounds that plants use to defend themselves against pathogens, which goes hand in hand with the one before that. So again, molasses, making your plant more ISR, more stress resistant. Seaweed extract, biocompound seaweed, natural PGRs, complex mixture of bioactive, also enhances natural immune system, also contains a range of micronutrients like iron, zinc, and magnesium. Note the difference between kelp and seaweed. So seaweed extract is basically anything that comes from water, whereas kelp is a certain specific area and a specific color. So kelp contains a variety of essential nutrients such as potassium, nitrogen, magnesium, trace minerals, all of which crucial. Also contains natural growth hormones as cytokines, auxins, which you get in basically those two products, and gibberellic acid is basically the basic of any PGR that you can buy out there. If you get kelp, you get those two for free. So it's a more natural way, it's a pretty natural PGR. So when you use kelp in your program, you get those two, and like Joel calls it, roots and shoots. That's basically what those two promote, is roots and shoots. You get growth above ground, you get growth below ground. So what else? If you want to go look into it, you can spray milk, you can spray coffee, you can spray vinegar. Russell uses Mountain Dew and furrow. For those of you who haven't tried it, go put some Mountain Dew in your starter furrow and see what comes out the back when the combine pulls in. Coca-Cola, same thing. I have definitions of those for those that want it, but it's pretty interesting. There's a ton of products out there that people are using that you wouldn't even think of that's being used as either a foliar or in furrow or some part of some compost tea, which is pretty cool. But again, when you have an inquisitive mind and you can't sleep at night, the amount of stuff that you can come up with is pretty amazing. So this is going to upset quite a few people, but this is something we've been experiencing the last few years. So I call it the multivitamin effect. So plants may be able to be more efficiently absorb and utilize nutrients when they are present in lower concentrations due to the fact that lower concentrations are closer to the optimal levels for uptake and utilization. When nutrients are present and high, they can compete with each other and lead to imbalances. Again, we're back to the Milder chart. Some nutrients become toxic to plants at high concentrations, leading to physiological disturbances. Lower concentrations of nutrients may lead to a more finely tuned hormonal response in the plant, allowing for better regulation of growth and development. So, cover crops. Who in this room plants cover crops? Okay. So, you have seen that when you go and look at sun hemp, the rate is 10 pounds. When you look at sorghum, the rate is 10 pounds. When you look at cowpeas, the rate is 8 pounds. But when you put them in a mix, you don't stick with those rates. You cut it by 3 or by 4 or by 5, depending on how many components you got in that cover crop mix. We're doing the same thing with foliar. If I mix 5 products, then I divide the rates on those products by 5 times, and when I apply them, I get a more response out of that than I would have had out of every one of them in a single deal. So instead of going out and addressing a deficiency, which we still do sometimes, we actually use our foliar like a multivitamin on our corn, on our sorghum, if we do a tissue sample and we're showing an equal line, that we're no deficient in anything, we're still putting something on, but in very, very low concentrations. And when we do a tissue sample 7 days later, we're seeing a bump in everything. So this is something we've been playing with and upsetting the dealers and retailers, because we're seeing 3, 4, 5, 10, 20 bushel bumps doing this at a very, very cost-effective way of still getting a mixture of a lot of elements on the plant. So basically, how to balance the scale. Do not over-apply. Jeff Razor taught me this on cover crops out west when we were trying to find our carbon to nitrogen ratio on cover crops, because when we started with big biomass cover crops 12, 15 years ago, we got our teeth kicked in because we had 0 crops after the cover crop, because we don't have the moisture to cycle that cover crop and get that biomass back in the ground. So we had to lessen down and slow down our mixes and slow down our carbon so that we can get Mother Nature with moisture to keep up with us and digest all that carbon. We're seeing the same thing with foliar. when we do a small amount of a lot of product, we're seeing huge bumps in photosynthesis. We're seeing huge bumps in exudation. We're seeing huge bumps in our mycorrhizal symbiotic relationships that are coming with it. So more is less is more when it comes to profitability and balance. Manage your inputs to find the sweet spot because every farm is different. Every entity is different. Your soil conditions is different. Your management's different. So that's something you got to play with just like cover crops. Find the products that work in your area and do some side-by-sides. Do not be afraid to try things. Soil pH, and this is again another deal from grain, but soil pH becomes self-adjusting when your calcium, magnesium, potassium, and sodium are in balance. So a lot of guys tell you that if you have an 8 pH or a 6 pH or a 5 pH or a 9 pH, you can't change it. We absolutely can. We have a farm that when we started was 8.8 pH in the worst spot, and right now it's about 7.2. And this is taken since 2009, so we're quite a ways into it. But you can affect and change your pH of your soil. So what we call the cheap Wild West. So I farm in the desert out in southwest corner where the Dust Bowl is, and everything that we do is cheap. Our margins are a lot less, our inputs are a lot less than you, our costs are a lot less than you, but our yields are a lot less. So basically, if you're having a $1,200 an acre input, we're at $120. So we got to figure out ways to make us profitable where everything is a tenth of what other people do. And when we start doing that, we don't always know the consequences because we're running in a direction to stay profitable. And then 5 years down the line, we're realizing that our milo and our soybeans will make 12 bushel with 1 inch rain. And then we're like, well, how's that possible? Well, when you start digging into it, you're looking at that plants may develop longer, deeper, and more extensive roots to access nutrients. Some plants store nutrients in tissues, such as stems or leaves. Plants can increase their efficiency in using available nutrients, such as reducing nutrient loss through leaching or by nutrient uptake. Some plants form symbiotic relationships with beneficial organisms, such as mycorrhizal fungi, that help them access and absorb. Plants may alter their physiology, and that's something that brings me back to the GMO corn and the non-GMO corn. We're seeing GMO corn and GMO soybeans having the same effect and having the same changes in their way they're accessing than what Mother Nature plants would be. So why? I don't know yet. That's what we're trying to figure out because we are seeing that our corn plants exudate just as good as what a heirloom would do. But we are putting photosynthesis in hyperdrive. We're doing things right. But plants may alter their physiology to prioritize the use of available nutrients, such as growth, reproduction, while reducing investment in non-essential processes. Over time, plants can genetically adapt to lower nutrient availability, developing traits to enhance their ability to thrive in nutrient-poor environments. Some plants can improve nutrient availability in their immediate environment by enhancing the cycle and recycling of nutrients within their ecosystem to feed microbes. Overall, plants exhibit a range of adaptive strategies to thrive in nutrient-limited conditions, ultimately maximizing their growth. So, like I said, this took me about a week to put this one slide together after study, looking at studies out west where we have put plants in a stressed environment, and after 3 or 4 years, those plants become basically starting to get more robust under the same conditions. So, best time for a foliar, 6 days before a full moon, 6 days before a new moon is the worst time. And again, this is from Graeme Sage, Nutrition Farming 101. You can go read it up, check it. I'm never on time. So this is one of those that the mechanic's car is always broken, but that's the best time to apply it, 6 days before a full moon, and the worst time 6 days before a new moon. And that's it. So I don't know what my time looks like, but we got Q&A. We got 10 minutes? All right, so if there's any questions, go ahead.
You think that moon thing has something to do with photosynthesis?
I have absolutely no idea. I didn't stay awake long enough to check that up too, but That's I'd probably have an answer next year this time, but no, that came straight from Graham. So that was one of the nutrition farming deals that he put us. 6 days before a full moon was the best one.
Going back to the beginning of your slides, talking about outlets, I know down by you, there's still some guys running on 20-inch spacing. You were talking about bigger leaves, and I know some people are observing that you can drop population, just change the way the plant orients itself amongst the rest. Have you seen anything with that or toyed with any of that with guys?
So 2009. So when I started down there in 2007, I don't know, people can still hear me probably saying fine. So when I started 2007, all the beans in Stevens County, Seward County was basically 30-inch rows. We started, when the air seeders came out, I think 6 or 7, we started playing with 10-inch beans. We went up 20 bushel the first year in APH. A lot of people are trying to limit airflow. We are trying the same thing. Like when you go east, they want to go wider to get airflow basically in the plant. The only way we can keep that 110 evap and 60-mile winds out of our beans is basically to come narrower. So the corn guys, there's one guy that might be here, I don't know if Terrence's here, but he plants 15-inch corn. And then there's a lot of 20-inch corn, and then everyone else 30-inch corn. So the fact that we're still 30-inch corn might be why we're seeing the big leaves and the big leaves on the soybeans also help us that, because the quicker we're shading out, the quicker we can create that greenhouse environment where we're building humidity. Our biggest problem is lack of humidity. So, we're 8, 10, 12% humidity on a good day with a 40-mile wind 5 days a week. So when we can get the flow out, keep the flow out of the field, is when we start seeing, a lot more production, a lot more photosynthesis. Any other questions? Steve, go ahead. Sorry.
Have you had any unintended consequences when you mix products at lower concentrations?
We have not had any problems by mixing anything in low quantity. I have had stuff bubble out the top when we brew stuff. And that's something that's kind of a joke in between us. But, we always jokes like after like the 17th products, like that one, do not put that one in next time. Because we have had it. Well, it's happened twice. We usually 500-gallon water, and then we start putting in the product. And you got to do jug tests, but, if you're like me, you don't. So you just keep adding. And so after like the 9th product, the foam starts shooting out the top like a volcano, and you're like, okay, whatever we did in the last, don't do that one again. And then you leave that one out again, and you keep adding another 2-3 products, and then you add that one in last, and it does it again. You're like, okay, it doesn't mix with the rest. And so we've learned and which products place nice with the other kits and which not. But the other side of it is when you mix phos and calcium, and you let it sit in the nurse trailer for a week, you're going to dig it out. And so that's the thing, is like whenever we mix, there's some management that goes hand in hand. So we usually, within 24 hours, it's through the trailer, and we'll stir it up every morning, every night when we pump it through the pivot or when we put a foliar on, because we'll use the foliar both ways. We'll put it the fast rate through the pivot, or we'll put it on through the sprayer. But most of the times we don't have problems, but we've seen that we mix calcium with phos, it'll settle on us. And then most of the stuff that's organic acids, we have one product that's full organic acids that's made out of corn syrup. It will start bubbling. Like it goes into brew mode, almost immediately. So yes, we've had some run-ins with that, but not because of the lower concentrations, more because of the amount of products. Because when we mix, it's usually between 8 and 20 products. I see Caroline in the back, but I've sent her pictures, but, sometimes we mix stuff and we're like, okay, this is not going well. And then next time we leave that one out. But we'll usually blend about 5 different products from about 5 different companies by the time we're done. No, I don't check pH for that, so. Go ahead.
What's your thoughts on like sulfates versus
I like for anything to be chelated, and again, she's in the back there. We use our fulvic acid, but I don't do anything without fulvic. It goes in, and I put it in the front. A lot of guys like to put it in the back. For me, it's like a buffer immediately because it chelates everything that goes in the tank when I put it in first. And I have a lot less issues when the fulvic goes in first. But we don't put anything foliar out without fulvic. And so I didn't want to mention into the fulvics because Danny had a talk and don't want to overlap. But yeah, she had a question earlier, and I don't know who asked it about fulvic and humic. So the question was for fulvic, in high pH, lowering the pH. Well, so fulvic for us, we don't use humic at all because humic, when you're in a low pH environment, it's hard to use fulvic in furrow because you're dropping the pH. When you're already at a 4 or 5 pH, you don't want to be putting more pH reducer in there, and that's what fulvic does. So when you're east of here, into eastern Kansas, where you have lower pHs, you might want to check and not use fulvic in furrow and rather use humic in furrow. But when you go west of here, where we have high pHs, we basically have ignored humic and just stayed with fulvic, both in furrow and as a foliar. So that's just something to keep in mind when you check the pH on fulvic and humic and which one you want to use, because one is kind of a quick breakdown, one's kind of a slow breakdown. Yes, Todd?
When do you start applying, and when is it too late to do the foliar application?
So we still apply nitrogen as a rule up until brown soak. And so I would imagine as a foliar that you can see the response within hours, especially nitrogen. I think until like a week before black layer, you can probably add nitrogen as a foliar and still see a response because it's within hours available. Now, there's some of the other ones that's more or less mobile that's not going to be. But generally, as a rule, after brown soak, we finish with our last fungicide, big micro application. Usually we wait and see if we got to spray for mites or we got to spray for, bugs or beetles. And that my beetle run will have that included. Well, the last 3 years, we haven't sprayed for that. So then we go in after that's all done, and then we'll run our micro.
Back on his question there. If I don't have pit, how late do I run a sprayer over? How late do I run a sprayer over?
I think on nitrogen, again, I think if there's a big rain event and you're at tassel or at brown soak, I think you're still going to see the benefit. We use an airplane, but yeah, I think a ground rig when you're going to start killing corn. Unless it's a high boy, I wouldn't run over tassel corn with a normal sprayer and start tearing up tassels. But we run a plane, try and get them to do 5 gallon. They usually run 3 gallon. We'll try and get them to run 5 gallon, and then we'll put everything on.
Do you have any thoughts or ideas, or does Willie have any ideas why you are seeing a 1-to-1 bacteria at 12 and 24?
So two things that we're suspecting. I don't have an answer. Like I said, we're going to start doing more 5-feet core samples and try and looking at the ratios, but the two things that we're thinking is, one, we were running the sheep on this specific farm. 2, we've been using a biological for 4 years. So between the two, we're thinking that I don't know, and that's what we're suspecting is the fungi. Fungi moves very, very large distances. So for the fungi to get down to 5 feet is not far-fetched. The bacterial, if you look at it, they don't move, but they're everywhere anyway. That's why you're usually bacterial dominated on most soil. So the fact that we're seeing a 1-to-1 ratio, which is pretty awesome, all the way to 5 feet deep, the only two things we can think of, since this is a very, very commercial tilled farm till 4 years ago, is for the last 4 years we have run both sheep and a biological in our system.
But would have you thought that you would have seen it closer to the shower there depth?
Well, the top 6 inches was literally the worst diversity. Now, it had the most biomass, but we were almost bacterial dominated in the top 6 inches. Now, again, if you look at my environment where we have 60, 70 mile winds, that we're suspecting that our environment is what's creating the sinus wave in our top 6 inches, which is, again, why I'm not on the Ponzi scheme of carbon because they measure the top 8 inches, and our top 8 inches looks like a casino. I mean, it's like up and down all the time, and you can't keep it stable. But deep carbon is what is stable. So the fact that we can look at the deep ones, now again, if you look at the biomass, our biomass is a lot less deeper than what we're top. So we got a lot of work to do to feed those bottom microbes. But the fact that we're seeing 1-to-1 fungal to bacteria ratio down that far deep, that's a pretty good sign and a pretty good base to work off.
Nick, what type of measurements do you use to decide when and where with regards to microbes doing foliar?
So we do tissue sample at 3-leaf, 6-leaf, 10-leaf, and tassel. And I try and do it every year faithfully. There are some years where I skip a process, but we have done some sap. I did sap. A lot of people are going to laugh, but we did sap samples in the 80s, and when I was a vegetable farmer. And so this is not new for us. But we don't use sap on the new, xylem and phloem deal. We just use sap as the crush test because there's tons of peer reviews on the normal crash, basically garlic press, check out and send it out, because there's some standards. If you've done the Graham Say deal, he's got numbers for every species on every stage on what the numbers are for, certain elements and certain minerals. So we've been leaning on that when we do the sap, but we've basically switched to a normal tissue sample, because if you look at tissue samples, it's never yield related, it's balance related. It just shows you the deficiency. Because if you take a tissue sample from a 300 bushel field and a 100 bushel field, you can't tell the difference. There's no yield measurement in a tissue sample, it's only balance. But when you can keep all the things balanced, you can push yield. Yes? When you got them in a straight line, basically. When you get a tissue sample back, every one of them is categorized as sufficient, low, deficient, high. So you can try and get them sufficient per stage. So they've got their basically, bottom line, baseline that they use. We try and be sufficient, but we also try and be at the higher level, but not toxic. So when you start raising everything, you'll notice that line, when all of them are just basically sufficient versus all of them are now starting to touch the high line and getting high. So you can still push it, the nutrients but as long as they're all balanced, you start seeing everything lifting up.
Just getting on that line and whatever the lab's saying is sufficient, getting them all in line.
I want to try, and so when we just shooting for dryland corn, if they're barely touching that sufficient line, I'm happy. If we're shooting for 300 bushel corn, I want all of them going higher, way into that sufficient. But again, it's a level of balance. So there's really no yield measurement on it, but as long as you don't have one out of whack, that's the most important. Any other questions? Is it beer time yet or not? Almost. We got one more.